Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at composite functions. So let's go ahead and get started. Now, first of all, I'm assuming you're familiar with the function. This is something where, you have like f of x equals, 3x minus 2 or something. This is a traditional function. And so you put in different x values and calculate the f of x value, if you will. That is what a function is. However, a composite function is when you have a function within a function. In other words, you have multiple functions going on at the same time. And so let me give you a picture of what this looks like before I give you the details. So let's say you have a function. You have your f of x function, let's say like 2x plus 1 or something. And then you have your g of x function. And let's just say that's like 3x minus 4, something like that. And so a composite function is where you do one function first, then you do the other function second, and that's when you get your final answer. Now, for those of you who are more familiar with like coding and computer science and things of that nature, it's very similar to nested functions. It's kind of the same idea, except they use a different term because it's a different discipline. So essentially what's happening is this. Let's say I want to know the following. I want to know f of g of x, like this. That's what I want to know. So essentially what's going to happen, and again, if you're familiar with computer science, when you have a nested function like this, you do the inner function first. So in other words, I would first calculate this guy right here, the 3x minus 4, and then I would take whatever the answer is for that and put it into this second function right here. So if I had to draw you a picture, it would look like this. So you have your x value, whatever that's going to be, and then that's going to go into your g of x function, and then the output for the g of x function is going to go into the f of x function, and then you have your final answer, which is going to be f g of x, like so. We've been talking about that. So that's kind of the overview of what it's like, but there's several different types of there's one type of notation that you have to be familiar with when you want to do this. So far I've been using this notation. This is kind of one common one. But another way to write this is as follows when you're dealing with composite functions. So it'll be like parentheses f circle g x. So that's literally what it is. F circle g x. It's the same thing as what we have right here to the left. It means find, the fg of x is basically what it means. And so these two types of these two types of terminology, or these two type of ways of writing out the expression are commonly found. So after giving you this theoretical stuff, why don't we do a couple of practical examples to make it clear, because right now I think it's a little fuzzy. So imagine we have the following. We have these two functions here. So we got f of x equals 3x minus 2, and then we have g of x equals 5x plus 1. And so the first thing we're going to figure out is the following. So the following, this is what we're going to know. We want to know, f circle g x. All right, this is what we want to figure out. So in other words, here's what's happening. F circle g. In other words, f is going to be the outer function and g is going to be the inner function. That's what's going to happen here. And so if we do that, this is how you handle this situation. You put the f like so right here because it's the outer function, and then you put whatever the inner function is. So for our purposes, it's going to be 5x plus 1. That's it. That's what's going to be on the inside of the function at first. Now, watch carefully what we do next. Notice how I got this 3 and this 2. Watch what I do. Bringing this down, I have the 3, and then inside parentheses, I have 5x plus 1 minus 2. Now, where did all this come from? I am taking this right here, and I am substituting it for the x value right here. That is what I'm doing, because that is how I'm able to calculate f circle g. So now it's just a matter of doing some basic algebra. There's nothing unique here that we haven't seen before. So understanding the distributive property, we do 3 times 5x is going to give me 15x. And 3 times 1 is going to give me 3. And then I still have this minus 2 left over. I simplify, and I get my answer, 15x plus 1. That's it. Not that deep, not that complicated. Very, very doable. This is just an extension of things that we've learned in the past. Let's do the opposite now. So let me rewrite my equations here. So let me go back real quick and rewrite my equations. Oh, let me write my equations. I'll just go right here. All right. So I still have my f of x. Oh, whoops. F of x equals 3x minus 2. And then I still have my, let's see here, g of x equals 5x plus 1. Now let's do the opposite. This time we're going to find the following. We're going to find g circle f of x. And we know what that means. We know that that means that g is going to be the outer function and the inner function is going to be the 3x minus 2 because that's what f of x is. So 3x minus 2. Now, you've seen this before. All we got to do now is take g. So we're going to substitute 3x minus 2 for the x in the g of x function here. So now I have 5 because that comes from my g. And then for x, I have 3x minus 2. And then I still have that plus 1 on the outside. Distributive property, I get 15x minus 10 plus 1. And then for my final answer, when I simplify this negative 10 plus 1, I get 15x minus 9. So you can see that when you flip the functions, you don't always get the same answer. It really depends on what the values are. Now, there's one more that we need to cover that we commonly see as well. But this is not so much a composite function as it is multiplying two functions to make a new function, if you will. So another thing that you commonly see is, again, let me rewrite my function here so there's no confusion. Oh, rewrite my function. So first of all, we got f of x equals 3x minus 2 and g of x equals 5x plus 1. Now, you also frequently see this. You see f dot, and what I mean by dot here is multiply, this is not a circle, g of x, which essentially equals, you probably already know by now, f of x multiplied by g of x, like so. So again, there's nothing deep here. You've seen this before, at least partially. So you have basically 3x minus 2, 5x plus 1, and just use FOIL method to figure it out. So if I had to work on this real quick, I would say 3x times 5x is going to be 15x squared. 3x plus times 1 is going to be plus 3x. Negative 2 times 5x is going to be minus 10x, and negative 2 times 1 is going to be minus 2. And then you simplify that by combining the 3x and the negative 10x, and you get the following to wrap it up. 15x squared minus 7x minus 2, and that's essentially the end. So let me go back and review what we talked about before concluding this video. So in this particular video, we took a look at composite functions. And composite function is basically when you have two or more functions being used together to create the final answer, if you will. And essentially all you have to do is that you just have to know what your two functions are, and you have to plug them in as appropriately. They have some terminology of that. It could be f g of x like this, or to the right here, it could be f circle g of x as it is. And essentially, the inner function always goes first in terms of the output, or you could say that the second function always goes first in terms of what you do. And you just follow the steps appropriately. And so then here we have an actual example here where we follow this. We had f circle g. And so we took the f and we replaced the x of the f of x with the equation over here for the g of x. I hope I'm not losing you with saying all that. And so you plug that in first, and then the next thing you do is you just distribute it as appropriate. This 3 came from the first function. This 5x plus 1 replaces the x right here. It came from this guy over here, and etc. And then we did the opposite where we did g circle f this time, and it's the same process, not a lot to say here. And then the last thing we did was we looked at this example right here, where sometimes we're called upon to multiply two functions together, which is not that complicated because in this particular situation, the two functions that we have are just binomial terms. We just use the FOIL method to get the answer. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.